Sorry about that. Got to have the microphone up close here. Me a little far away, but the microphone close. Sorry about that. Sorry about that. Uh, so, yeah, this is Astronomy Daily Live coming at you every single day at 2 hours UTC. Glad to see everybody there. I'm assuming that you're hearing me a little bit better now. So yeah, I just start yeah, just start talking away. Um, so yeah, this is a circle of friends talking about astronomy, mostly astronomy. I've just um, I'm through the early stages of being able to run a live stream on Twitch TV through OBS. And what I was saying uh, was that uh, I was trying to get it to run on my Linux machine, but it just wasn't doing it at all. So I had to switch over to this laptop, which is running Windows 7, and successfully installed OBS, successfully connected to Twitch, and successfully saw myself live streaming on my twitch.tv channel. I guess it's called a channel. Um, but not quite sure exactly why. But I was getting a lot of latency and a lot of freeze frame, with the spinning thing in the middle. So that's a, uh, a small obstacle. I just started this whole process maybe an hour ago or so. So yeah, it's like completely new. So yep, hope everybody is good. Thank you for the confirmation on the good sound OMC triple X. And so if a planet was made of, I assume you mean macaroni, and a moon was made of cheese, would you orbit in between for infinite calories? No, actually, if you orbited at the at the point between those two objects, um, where the pull from one equaled the pull from the other, since they're in opposite directions, you would be in a at least a microgravity environment, very 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 small. Um, so yeah, that would sort of be the opposite of infinite. That's pretty close to zero. So, and that actually is a physical thing. It's one of the Lagrange points, and there are different Lagrange points um, uh, uh, in the area of a planet or a moon or any kind of body. It just requires the relationship between two or more um, objects in space. So I guess um, I guess to answer your question, um, I don't think that I would orbit in between. No, because yeah, that would just you'd feel a little stuck. So yeah, definitely not. Hey there, Lord. Nice to see you back. Glad you stopped in. You know, this is just a casual gathering of friends. It's uh, as I said last night, nobody but me is required to be here every single day. You've got other things going on, um, other channels to watch that are more interesting, better, whatever. So, but that's one of the cool things about having a daily stream is that uh, we'll always come back around, to things, and the circle of friends will always be here. So yeah, really, really awesome. Having said that, I'm here every day. Tomorrow, I will not be live streaming. I'm going to be going to that art exhibit at the University of Arizona at the Lunar and Planetary Lab. I was emailed just about an hour ago also, informing me that in the data art category, I have received an honorable mention. So that's not first, that's not second, that's not third, and I think there are like two honorable mentions. So yeah, I think that's uh, pretty cool. There were 200 entries, and you know if you're counting or measuring things via how much you win, then getting an honorable mention, that's about I think there were something like maybe 13 awards or so. So yeah, it's not bad, not bad. So that's going to be fun. That's tomorrow. So I will not be live streaming tomorrow night, but I will be back the next night. Microgravity, less calories. Would you go there to lose? Yeah, for sure, because moving around is um, there's there's nowhere to go, and there's not a lot of resistance. So yeah, you're gonna lose it. Uh, Might be a setting to change it. Yeah, yeah, I think so too. I mean I am literally 1 hour into OBS. I saw how I could change the resolution on the Twitch, but haven't figured out how to change. I'm pretty sure that I just have to modify the bandwidth here, and I mean I've literally been looking at OBS for maybe half an hour or so. The full work I've done on it so far is an hour. So, and it seemed to work. So that's cool. That was really really easy, and I like that. Um, so can the sun go nova, and if so, how? Yeah, I think the what the story is at the moment is that the sun in its core is fusing hydrogen nuclei, protons, um, into helium nuclei, which are two protons and two neutrons, and that process of fusion, of nuclear fusion, um, produces these helium nuclei, which are otherwise known as alpha particles, uh, and energy. And so that energy is radiated outwards because it's a sphere. So it starts in the center and moves outwards, and that energy, is transferred into different uh, means of getting out. Right? I mean, light wants to go away from its source, not the other way around. So we're basically dealing with light. Heat is a form of light. It's just a very very long wavelength, and it's something that you can feel as opposed to C. But it's kind of interesting how closely um, related feeling things and seeing things are, depending on what wavelength of light you're dealing with. So there's, as the story goes, there's a lot of hydrogen. There's a lot of protons in the sun. It's a large object, and for other reasons more complicated, um, which we can get into. It's dealing with the whole idea of the structure of the sun, and what's the interior like and what's the atmosphere like, and there's a profile of what what stuff is at what layer. Gets complicated, but on a very basic level, there's just a lot of hydrogen, or protons, really, hydrogen ions. So it's just an ion soup. It's like a plasma. In fact, it is a plasma. Um, so this fusion is thought to go on for about well, in total, about 10 billion years or so. And we currently think that the sun has been sort of doing this process, which is sort of a first stage um, after a star is born. A star is born uh, not only on the movie screen, but in space. And yeah, we can talk about the formation of stars, but once a star is formed, um, it that's sort of the definition of this first um, proton or hydrogen fusion stage, and all that energy is pushing out, but all the matter uh, is causing gravity to pull everything in. So at some point, luckily, uh, our star has reached um, uh, an equilibrium between the pushing out and the pulling in, and that's what's called the main sequence star. And stars, you know, the mass of our sun goes through this phase in about 10 billion years or so. Uh, yeah, I'm not going to get into stellar evolution either. So, but it's as much hydrogen as there is a finite amount. So after 10 billion years, it starts to run out, and so the story goes, um, that outward um, pressure begins to get less and less and less. So gravity begins to win, and the star begins to shrink. It shrinks and shrinks and shrinks. Um, but that added pressure raises the temperature inside the star, and eventually the temperature and the pressure is enough to start um, helium fusion. It's more complicated than that. It gets really complicated after that. But it's more or less, alpha particles fusing into, I guess, what would be mainly carbon and oxygen um, nuclei, and that releases a huge amount of energy, which can produce a nova. And usually, what you have left over, so that that and I'm going to back up. Most likely, the nova hasn't occurred yet. We need one more stage. It can go nova at that point, but probably not enough energy quite yet. Um, but there is enough energy for the um, um, the outer envelope of the star to expand and turn into a red giant. So again, it sort of reaches um, equilibrium, uh, and then it burns helium for a while into carbon and oxygen. At which point, um, a number of things can happen. If it's a star like our sun, then the um, the helium fuel will run out, and the pressure will again get less and less and less um, until there just isn't enough pressure at all. There's a collapse of the core and a little bounce, and that little bounce blows the outer atmosphere and probably a lot of the star itself, a lot of at least the atmosphere of the star, the near atmosphere of the star, blows that out, and that's what would be called a nova. Now, if the star is larger than about 1.5 times the mass of the sun, then there's a good chance it's going to go supernova. Uh, and then the star also turns into a neutron star at that point. I've got to think about all these things because uh, it's nice to remember things that one doesn't think about for a long time. So I think bear with me a little bit on sort of spewing the facts, but yeah, I think over time that will improve because I will remember more. I can certainly look up stuff and bring it into the group, so no problem. Hey, Warnock 69 Triple X. I really like your green. Uh yeah, you look really good that way. Yeah, yeah, I approve. I approve. So that's pretty much, yeah, that's the story of the sun. Is that at least the current thinking on things, constantly subject to change, but the current thinking now is that our sun uh, will nova in some way, resulting in a very very small, dense white dwarf star, surrounded by some kind of nebulosity, which would be the remains of the atmosphere of the sun. Um, the Earth's the Earth's fate is it'll be fried when the sun turns into like a red giant. But uh, there actually there's some interesting information about that I I don't know if uh, this is true or not, but it almost makes sense. I was watching Tony Darnell's Deep Astronomy show a couple of weeks ago, and the people on there were like five guests and Tony. Okay, five guests and Tony. Okay, and all five guests, they were all astronomers. Okay, all five guests said that um, we only have 200 million years until the sun uh, and I forget exactly how uh, um, they put it. I should go back and listen to that. But they kept saying, you know, things like 200 million, 100 million, 500 million is too much. And I that immediately caught my attention, and it also immediately caught Tony's attention because I think he and I were both taught that it's more like 5 billion years, 5 billion years until our sun turns into a red giant and engulfs the Earth. The Earth is gone by that point. It's gone, and that really it freaked me out at the time because it's like, okay, all these astronomers are in agreement. They've heard something. They've heard something that I haven't heard. And, you know, I I try to pay pretty close attention uh, to all things astronomical. And I'd never heard that. Never heard that before at all. So, the first thing I thought is it's like, well, shit, I've got to change my plans. I've got to change my plans because all of a sudden, um, what is that? That's oh, by the way, I haven't mentioned this in a couple of shows. All good scientists, especially all good astronomers, have a calculator on their desk. And it's got to be a scientific calculator. It can't just be sort of an adding machine, right? I mean, it's got to have all the you probably can't see that really well because it's not going to focus. But yeah, just all the standard scientific stuff. Anyway, 200 million. Okay, 200 million is 200 exponent 6 divided by 5 billion exponent 9. Okay, that's um, that's like 96% less. So, all of a sudden, you know, my plans for my 5 billion year plan has just been knocked down to a 200 million year plan. And that's I immediately thought, and I'm pretty sure that Tony thought this too, and that is, um, that's not right. There's something really, really wrong with that. Really wrong. But how can it be that five astronomers um, who know their stuff, right? Who know their stuff? How is it they're all in agreement? How do they know? And at least two of us, Tony and I, had never heard this before. And he kept asking them that, and they kept the same story over and over and over again. So anyway, I was just like, oh, that's just wrong. That's just totally wrong. What are they talking about? You know, but it's like they think they're right. So what do they think they're right about? And what I realized, and this this can almost make sense. Okay, the sun turning into a red giant is not going to happen overnight. It's not going to happen in any kind of sudden way. It's going to take a long, long, long time. It's going to be very slow, very, very slow. But what I think I've realized is that 4%, a 4% change, a 4% change in the sun's behavior, cooling down or warming up, getting bigger, getting smaller, a 4% change is a really big deal. That's a really, really, really big deal. That that's going to uh, I mean, if all of a sudden, 4% less energy was hitting the Earth, I think that would be devastating. Yeah, I think so. So what I'm coming to the conclusion is that what they mean when they say 200 million years is that we're going to start really, really feeling a difference in 200 million years. That's when it's going to start. That's when we're really going to start, feeling that, you know, that's about time. The cool thing is really, right, is that in 200 million years, human beings aren't, I mean, if you follow, the evolutionary path, human beings like this, I mean, in fact, pretty much everything as it is now is not going to be here. It's not going to be like this. I mean, think back, 200 million years. It wasn't like this. So there's no reason to believe that it's going to stay the same as it is now. There's no reason to believe that at all. That's not logical. Tom, the sun ga- puts out more gas as it ages. In about 300 million years, it'll be too hot for liquid water on Earth. Okay, yeah, I think that's sort of the same thing that I'm saying is that we're going to start feeling it then, but um, I think there probably is still a consensus that by 500 billion years from now, we'll have, I mean, our sun will have become a red giant. Does that make sense? So it isn't just a sudden thing, boing, and you know, one day or 1 week or 1 month, you have a regular old star, and then next time you wake up, it's a red giant engulfing the Earth, and it's like no, that's not gonna work like that. It's gonna be some kind of a process, probably a very very gradual one. So yeah, the sun puts out more heat as it ages. Yeah, I I, that's correct. The luminosity changes too. So the overall brightness changes. It puts out more heat because the nuclear reaction that is taking place is more energetic. That's also what makes the star expand um, into a red giant. So in about 300 million years, it'll be too hot for liquid water. That's the part that I'm not following you there, Tom. Yeah, Katie, thanks for coming in. That's awesome. You are a new face or a new name. So thanks for coming in. That's awesome, awesome. So she's saying that the Earth won't be consumed. The energy released from the sun going red giant could be enough for Earth to be knocked out of orbit. Okay. Yeah. Yeah. It's uh, a lot of what I sort of go back to is the fact that we're relying on models to sort of predict things, and models are it's first you have to set limits. um, that's really really hard, and then you have to actually set the parameters of the models themselves, and a lot of the parameters are not only complicated but also are models. So it gets really really hairy, and I think there's always room for error. So uh, yeah, the Earth is. I mean, I think there is a consensus that if you follow uh, uh, the storyline to the end, then the Earth is uh, for sure probably left lifeless. Um, Probably not uh, in any kind of a condition to hold any kind of life. Um, but who knows? They're talking about planets that live inside the atmospheres of red dwarf stars. So how cool is that? How cool is that? Uh, Energy released from the sun. Yeah, yeah. So what? Uh, Regardless of sort of the details, I think the Earth is SOL, right? I mean, uh, at least according to that story, the Earth is screwed. The inner solar system is screwed. So yeah. Um, so Lord asks, have 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 you found any evidence of evolution in your studies in astronomy? Do you mean biological or um, physical? I guess because if it's uh, biological, I can't say that I have personally witnessed evolution. I've I've uh, I've seen evidence that points to um, evolution, and of course that information is you know uh, ultimately based again on models, on guesses. So it's sort of the best guess. In terms of uh, um, um, physical evolution, well, the isn't it the zeroth law of thermodynamics? Uh, is the law of entropy? Is that the zeroth law? Catch me on that. I don't know. Should I check? I think I should check. But entropy, uh, I believe, is understood to be entropy, entropy. What does it say about entropy? I think, yeah, I mean, entropy is going to force things to evolve because living things do not want to accumulate entropy. They want to remove entropy. They want to make things more structured, more complex. And entropy is going the opposite way. Scratching kitty. Um, it's the second law of thermodynamics. Second law, law, law of thermodynamics. Uh, let me define a law. A law, to me, at least, and how I will speak of laws. A law is a rule that cannot be broken. So, is this a law of thermodynamics? I don't know. I don't know. We're pretty sure. We're pretty sure about this one. But cheers. So we observe entropy, and therefore, at least in the physical universe, evolution occurs. And yeah, Katie, I would agree with you. I wouldn't necessarily say incorrect, but maybe either misunderstood, misinterpreted, not stated correctly. Um, yeah, you know, uh, they are subject to evolution. So yeah, yeah. So yeah, in terms of you know um, um, physical evolution, the evolution of systems. Um, yeah, yeah. You see it all over the place, and you see it uh, live in real time. Yep, it's happening on the Earth right now. Yep, you can go watch volcanoes go off. That's a disturbance in the entropy. So yeah, Katie, I like your energy. Glad you came in. This is a very informal circle of friends that are talking astronomy. Um, very open-minded, but very skeptical. So talking about things in here, we can definitely disagree and discuss things. And yeah, I'm wide open to lots and lots of ideas, especially things that I don't really mm, know a lot about, because then I want to learn more. You know, things that I think I'm pretty familiar with. That's sort of where I get into the skeptical part. If I hear something that isn't exactly what I had learned or thought or figured out or anything, then it's like, look hard at that. But new stuff, I'm open. And if if what I think is not right, or I'm not looking at things right, I will correct that in 3 microseconds. Yeah, three, three though. Okay, got to give me my three. Yeah, I don't mind typing a lot. I do that myself as a programmer. I type a lot too. I've gotten so yeah, I can type uh, at least as fast as I can talk. So and yeah, can sometimes have a conversation while typing something else. So yeah. So, but yeah, I don't mind. This is an open circle of friends. So come on in, and you know, if you have some sincere um, conversation or topics, then you are welcome to type as much as you want. Now, if you get annoying and stuff, I am the hammer, and out you go. But this is, I want to keep this really, really loose and really, really fun. And don't worry too much about any of that. So yeah, I mean, you would have to do something pretty naughty to to be tossed out of here. So maybe that's a sign of popularity, right? So when I start getting the naughty ones, uh, then I know that I've arrived at phase zero, right? Yeah, Katie, I would say study anything that you are interested in, and if you have a passion towards um, string theory, um, any any of those things, don't don't listen to anybody about what you should do and all of that. Just dive into it, dive, and at least in my experience, and I'm much older than what you might think. Um, in my experience, if I'm not supposed to uh, go down a particular path, there's going to be a wall. There's going to be an obstacle that I cannot um, go through. And so what I do is I just stop and it's like, okay, I got to go back and I choose another path. The next path, that looks interesting. So yeah, I would say study study anything you want, uh, anything that you have a passion for. Um, Go for it. And science is art. Science is a creative process, and that's art. And so yeah, there's a lot of really really awesome things. Mathematics is is uh, is like one of the most amazing, and I can call it this because I consider myself a mathematician also. It's an amazing fantasy land. That's not to degrade it in any way. Fantasyland is really, really awesome. It's beautiful. It's gorgeous. There are just incredible places that you can go inside of mathematics, and they're wild. And if they're useful, if they're useful, ah, then they're real. So you know, no worries. Did you see what that kitty did? And now, and now she's drinking the hydrogen hydroxide. Hydrogen hydroxide in cats is okay though, so no problem there. Oh, haha. So Lord, how many galaxies have been discovered out there in space? Um, yeah, and Katie is correct. I would say that's a very very large ton. Um, yeah, lots and lots and lots. I want to. I don't have the numbers in my head, so I'm going to be pretty rough with this. In fact, what I can do is I can look it up. Let me share my screen. I haven't done the screen share tonight yet, and it's already 43 minutes in according to my clock. So we're going to go to infinity, and then we're going to go over to the browser, and the kitty is not going to drink out of that. And I want to go to, oh man, the kitty distracted me. Kitty totally distracted me. Oh, that's right. Okay. So what I'm going to look for is called the Hubble Deep Field. Hubble Deep Field. And you've probably at least heard of this, if not seen it. And then what I want to get from this Wikipedia entry is I want to get the size of the Hubble Deep Field, how many square degrees, and okay, so it's 2.6 arc minutes on a side. Okay, so it's 120. Okay, here you go. It's 1/24 millionth of the entire sky. Okay, that's the first piece of information. So that's a really, 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 really small portion of the sky. Now, the other thing that I want to do is I want to know, it's trying to drink the hydrogen hydroxide, and it's like, kitty cooties is just not my thing. Now, what I want is to see if it says how many galaxies. Okay, so 3,000 distinct galaxies can be identified. Okay, so 3,000 over 1/24 millionth of the sky. Okay, so if you, and this is the number of galaxies, right? So that would be 3,000 times 24 million, because it's uh it's 3,000 divided by 1 divided by 24 million. And if you do a little bit of flim-flamming around, you'll realize that it's 3,000 times 24 million. 24 million. It's exponent 6. So that's 72. Is that right? 72 billion? 72 billion in the entire sky. So 72 billion based on that data. Does that sound about right, Katie? You seem to sort of be in the know with these kinds of things. Is that 72 billion? That seems a little low to me. I think I've heard bigger numbers, like in the trillions. Um, but maybe I'm wrong about that. Oh, and Tom's saying somewhere between 200 billion and 2 trillion. Yeah, that's a huge range, but you know, based on the information we have, that's probably about as good as we can get. Um, uh, so yeah, based on the Hubble Deep Field, okay, based on the Hubble Deep Field, I'm getting 72 billion galaxies. Now, I think they've done a number of deep fields with Hubble. Um, maybe, uh, and I think they did some deeper fields. So maybe uh, that number is more. So maybe I would set this as a lower limit. So at least 72 billion galaxies, and a modest galaxy, a modest galaxy will have 500 billion stars. So let's multiply the number of galaxies by the number of stars in a galaxy. So that's, what did I say, 500 billion? So 500 exponent 9. So that's 3.6 times 10 to the 22nd. So 4 followed by 22 zeros is the number of stars in the universe based on this really, really rough data. So, don't don't get too bogged down in any of the numbers. Um, yeah, it's fun to impress your friends with numbers, but yeah, I think I think numbers, especially big ones, are sort of overrated. Um, we, I mean, why why try to take that big of a bite when the little pieces are, you know, have individual tastes and individual textures. So, why bite into the whole thing? That just seems a little too big. So yeah, apparently, and this is just the story that I hear, is that the Andromeda galaxy, which is the nearest uh, sort of large galaxy to our galaxy, um, is on some kind of a collision course. But I think what Katie was saying, yeah, I mean, the empty space, um, you know, collisions, collisions are going to happen, right? But there's a lot of space in between, like stars. So the possibility of that taking place, that's mm, they're just going to sort of slide by each other. They are going to interact, gravitationally. So orbits will change. I'm back. I'm back. Um, orbits will change. Uh, yeah, I mean, it's going to be exciting, but yeah, probably very, very few collisions. There's going to be many more. It's a numbers game, so the more stuff there is, the more collisions there are going to be, because there's just more stuff. So small things are going to collide a lot more frequently than large things. Um, Everything, though, is going to be perturbed um, in a gravitational sense. Nothing will survive, um, probably not being perturbed in some way. And yep, I'm one of the and this is just because I'm a skeptic. Just because I'm a skeptic. But black holes, I'm just not too sure about. Not too sure about. Never have been. Never. Um, just a lot of things bother me about black holes. So, and maybe that probably what that is just a lack of understanding, because but that's one of the problems that I have, is that black holes get pretty complicated pretty quick, and I'm wondering if that's us complicating things, making seeing stuff, making observations, collecting the data, building models, see how they match. Good match, probably a good model, but I mean, it comes down to correlation isn't the same thing as causation. So it's just, I don't know. I've always had a hesitation about black holes, and that remains. So yeah, as far as I'm concerned, black holes are still sort of up in the air. I I know that uh, people who are much more in the know of these kinds of things um, are more um, convinced. So it's entirely possible that I don't know enough to be able to put the pieces together. So something for sure is interesting happening in the centers of most galaxies. Um, there's other interesting things that I don't know. I don't know. I've got to say I don't know. I'm agnostic in many, many, many ways. So I don't know, and I'd like I'd like not knowing, because then I guess if nothing else, it you know gives me something to do and something to worry about. So yeah, I Tom, I am I'm totally with you on that, and but you know throughout history we've said that over and over and over again, and I don't think that our time now is really significantly different than what it was in the past. Things change, and changes, but um, yeah, I don't um, I don't I don't know. I don't know. So Katie, my education is uh, sort of a unique one, I guess. Really, really, really early on, and I'm not going to talk a lot about this, because yeah, it's well, more and more things will leak through as time goes by. I definitely consider this group friends, but we're still in the process of sort of getting to know each other, and you know um, and I've got to be um, verbose and frank about that, because it's hard to read body language and anything else when it's just a talking head. So I've got a wild kitty in here tonight. Um, I went to the University of Arizona as a major with astronomy and physics, and struggled struggled a lot, um, main, mainly because, and I realized this at the end, that I just I don't learn well in those kinds of environments. So, but the one thing that I learned early on is I learned how to learn. So I, uh, from earlier on, I was teaching myself stuff, and that's how I've gotten uh, most of what I know. So struggled at the university, had a great time, great people. Um, Most of the teachers, I would say, were like just awesome. Just, I mean, really knew their shit. Were experts in fields. Taking their time out sort of because they have to, to teach. A lot of them wanted to though. So awesome, awesome. They're doing, lots of research and they're teaching. That's a big deal. And so I was taught by some of the best there are. The University of Arizona is sort of the uh, at least one of the astronomical centers of the universe when it comes to getting an education. But yeah, the 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 teaching methodologies that are used just don't link up with my head. So I had been working at Stewart Observatory as a student all this time, and so developed a reputation and was offered a staff position prior to graduating, um, and that took me about, well, I want to say two microseconds to say yes. So yeah, didn't formally graduate. Went through, you know, pretty much almost done. So it was a kind of a strange decision, but being independent, I wanted to. I thought taking that route might be a little bit more interesting. I had seen how um, PhDs in the field spent their time, and I didn't want to spend at least half of my time writing proposals for money. I uh, I wanted to have keep my hands dirty, keep myself in the dirt, doing really cool shit, um, and not worrying too much about uh, who needs to get paid. Um, uh, you know, Somebody who's into that kind of thing will be much happier than I would be. So putting sort of purposely putting myself in a position of uh, not having the paperwork um, has definitely made things a lot more interesting. Uh, Having a lot of fun, still having a lot of fun. It's uh, it's rough. It's rough, but it's awesome, and it's my path. Not for everybody. Not for everybody at all. So, um, yeah, if you're thinking, Katie, of a major, that's you know that's something that, and I'm sure that you've been told this. It's something that you really don't have to make a serious decision until junior year, right? The first 2 years of college is just a lot of requirements. You got to get your requirements out of the way. You got to take your English courses. You got to take your psychology courses, all the basic, just to show, right, just to prove that you have a grasp of the basics, right? And then starting your juniorish year, you can start taking courses that uh, uh, follow your passions and um, expertise and um, those kinds of things. Yeah. I, this cat is gonna kill us tonight, and she's drinking the hydrogen hydroxide again. Bad kitty, bad. She's looking at me like, why am I being so rude to her? So yeah, but it sort of looks like you're leaning towards like a physical science, yeah, because you're talking about chemistry, astrophysics. So yeah, um, try to find the sound of your heart, and your heart will lead the way, and you'll find it. You'll find it. Now, what I did, I mean, I've known that I was going to be an astronomer since I was born. I'm gonna take 3 seconds, and I'm gonna let this kitty out, because otherwise she is going to start you know crawling on the ceiling. So 10 seconds. It is very, very awesome to have a nice little crowd in here tonight. I really, really, really appreciate all the support. I hope you like this. I mean, I'm open to criticism. I mean, if I can do something different, uh, or new, or have a regular thing. Hey folks, it's 7:35, and I want to talk about the news. I don't know. If you have any ideas or anything, um, I definitely I'm I'm uh, I think I'm filling a little bit of a niche in that this is a daily show, um, just talking about astronomy, not really uh, any empty space or anything else. I like the conversation to flow and flow anywhere really, as far as that goes. So yeah, for now, Katie, I hope that satisfies your um, curiosity. Um, a lot of what I claim to know, I've learned either through experience, where I've decided that I wanted to solve a problem, or I wanted to dive deep into the analysis of some astronomical data. Could be a lot of things. Um, I've just learned all of those things pretty much on my own, right? But I just learned how to learn early on, and so learning isn't I've got a process, and works pretty well. So yeah, no regrets, not at all. No, I'm having too much fun, and I hope those that go through sort of the regular thing, if they're having fun, if they are enjoying the whole thing, then who am I to say anything at all? If that's what your heart says, and things sort of line up, so you're able to do this, um, then do it. If you're happy, awesome. That's what it's all about. So yeah, that's what you got to do. But yeah, don't feel that you necessarily have to decide on a major now. You've got a little bit of time. As I said, I mean, I knew I was going to be an astronomer ever since I was born. So the way that I handled that was prior to starting classes at the university. I went to my what are they called? It's not a counselor, but oh, it's an advisor. Okay, it's an advisor. There was a freshman advisor, right? And I sort of explained, that I thought at least, that I was a little bit more advanced. Didn't need to take, the Astro um, 101 course, but rather I would like to take, this more advanced course as a starter. And so, he pretty much tested me right there. He sort of knew me already, but tested me a little bit, to see how much I actually knew, if I could handle um, sort of the higher level stuff. And he thought I could. So yeah, I was able to sort of mix in uh, my major classes uh, with the requirements. Sometimes that can take you longer because if you pack a lot in, uh, it gets tough. It gets tough. So, but I mean, if you're really good at being a student, um, you can breeze through that stuff easy. I'm just not that kind of a student. So you know, thick head, really thick head. Yeah, Lord, I'm going to be sort of baffled uh, as well, but I think there may only be four. It's just um, you guys are just talking it up, which is awesome. It's if there's only a few of us in here and it seems like a crowd, then we're doing pretty good, I think. I think, and I agree. I agree. Um, you know, I'm completely new at this, and um, uh, but yeah, as I said, I found some holes in what you know the um, the online astronomical community is doing, and so yeah, I want to fill a few of those holes. Nature abhors a vacuum, and I just happen to be nearby. So yeah, I'm going to try to fill a little bit of those holes. And uh, as I've said, and I will, say this again over and over and over again, this is a there's room for all of us, and I feel absolutely no sense of competition whatsoever, none. Um, you know, the other shows that come on, Weekly Space Hangout, Deep Astronomy, Dennis R. Hands. Check out Dennis Hands. If you're a newbie, really, really, really new, check out Dennis R. Hands on Snapchat. He is awesome. He is awesome. I have tried to contact him, to invite him on here, and I've gotten no responses yet. None. Zero. So um, hopefully that just means that he's for some reason somehow he's not seeing me. Um, Otherwise, he's ignoring me, and that's okay. Uh, yeah, no problem at all. There is space is big. Space is really really big. So there's a lot of room. There's room for all of us, and uh, I think it can be a synergy. I think having all of this and all of us and more of us doing this is very very cool. Is very very cool. There's a lot of a misunderstanding um, about some pretty basic astronomical things. Just the concept of time. Okay, I mean I intentionally say that this live stream starts at 2 hours UTC because I understand that grasping time, grasping just a basic concept of time is extremely important to um, begin understanding astronomy. And so that's sort of, you know, you having to figure out when that is for your location on this planet, because we're in time zones. um, that's a little task that you have to do in order to get through the door. And yeah, I think, you know, talking astronomy, you want to get in here if you want to learn anything at all. That's a really, I think at least, a really great thing to start with. Is start understanding all of our different concepts of time, because you know how it's measured, uh, what we think it is, you know, all of that. And you know, I'm figuring out uh, what time this live stream is on every day. um, is uh, is you know your first little task to get into the door. And if you're through the door, then uh, you've you may not realize how much you've actually grasped and understood. Just, you know, that simple idea uh, opens the door to big ideas, big awesome ideas. So I'm glad you're all here. Uh, Not as many in chat, yeah. So I'm glad you're here. As I said, you know, criticism is extremely appreciated. Um, I especially, you know, sincere, right? I mean, if it's just mean or anything like that, that's not. I mean, I don't care. I suppose if you want to be mean, but it's not too helpful for anybody, um, especially me. So criticism um, with some intent behind it, yeah, greatly um, greatly appreciated. This is coming off tomorrow. It's way overdue. It's way overdue. But yeah, I'm uh, sometimes pretty lazy when it comes to this stuff. So it goes for a little while, and then it goes away for a little while, and then it comes back. It's just a process. All right. I think unless you all have anything else for tonight, it's one of the cool things about a live daily show is that there's no pressure. It's like, you know, don't talk about something tonight, bring it up tomorrow. Speaking of tomorrow, remember that tomorrow night I am not live streaming. I'm going to be out. I'm going to be out at the art show, and yeah, I'm not going to be able to do the live stream, but I will be back the very next day, and don't see anything else on the horizon. So this hopefully this next thing will be a pretty long run. I'm not keeping track of the episode numbers or anything like that. That's too much. That's too much. It's hard enough to keep track of the date. So, you know, I'll keep track of the date. And if somebody wants to count all of these, that's that's cool. You know, it's data. It can be used somehow. All right, guys, I'm going to get back to messing with Twitch. Um, if you're watching Twitch and want to witness the antics, I'm cosmic underscore lettuce over there. Cosmic underscore lettuce, all lowercase. And so, yeah, I'm probably going to be playing with that tonight a little bit, see how far I can go. Got some bandwidth dials maybe I can set. We'll see how that goes. So glad everybody could come by. Glad you hung in there. Hello to everybody in the future. It's you know, the past was pretty good, but wow, I can only imagine what the future's like. So hello from the past, and I think I'm going to exit these waters and get back up to the you know what, and I will see you not tomorrow night, not tomorrow night, next night. So that will be 2 hours UTC on the 4th of February. By the way, tomorrow is Groundhog's Day. It is one of my favorite days of the year. Makes me very happy. I watched the movie, and I have a different interpretation of the movie than most. Maybe we can talk about that at some point. It's shared by a few, but yeah, I've got a different take on that. So, all right. Oh, okay, cool. Lord, I greatly appreciate all of the questions. Um, I guess, and maybe you can answer this really quick right now. Where are you in terms of the astronomy scale? Are you coming in this new? Um, uh, um, Remind me. Maybe you had told me before. Any kind of equipment, scopes? Are you a pro? The uh, the delay is awesome. Let's see if I can get an answer here. I don't want to keep anybody. I've got huge respect for people's time. So definitely don't want to. I don't feel as though I can just keep going on and on and on. Although I could, but I ain't gonna. I ain't gonna. All right. Well, Lord. Um, okay. Just learning. Cool. Okay. Yeah. Um, I'm glad you're here. I can certainly help. I am certainly not the only resource that you should be looking into. Um, there's a lot of online stuff. I can certainly point you in some directions. As I said, even for the newbies like yourself, right? Go to archive.org, look at the titles, see if there's anything that sort of is like, oh, what's that? What's that? Click on the PDF link, um, and honestly, look at the pictures and go from there. Um, I was trying to read journal articles way before I mean, I didn't understand anything at all. But I was diving into the journal articles, um, not you know thinking that I was pretty smart because I was reading a journal article, right? It's like, yeah, I wasn't reading anything. But you got to start somewhere. So archive.org for sure. Um, I think you've already talked about locating like a local club or um, that kind of thing. Those folks are usually very warm and welcoming, and they want to talk astronomy just like this. Yeah, they want to talk about what they're doing and the equipment that they have. A lot of them will have aperture fever, which is a common occurrence amongst amateur astronomers mainly. Um, uh, but yeah, so find a local club. There's a lot of online stuff. You're doing the right thing. You're hanging around, these kinds of channels. So, all right, very cool. Yeah. Check them out. They've um, um, the Thunderbolts project should not be discounted. Um, they're onto something, and um, as a scientist, right, I want to take a good hard look at everything that comes my way. I have, for me, the flat Earth is still jury out, right? I have no idea. And the reason why I have no idea is because I haven't studied that at all. I don't know anything about it, anything at all. So I honestly, I don't know. I think I've got some pretty good evidence that it isn't, but I want to see the evidence. I want to see how the data was processed, how it was interpreted, go through the whole thing, right? All right, I'm not going to keep you guys anymore. Um, but yeah, uh, open-minded and skeptical. That's that's uh, that's um, uh, that's my mo for sure. Open-minded, bring it on, bring anything in, but I'm gonna look at it really, really hard. Um, yep. All right, I'm gonna let you all go. Thanks for coming in. Hope you enjoyed. No live stream tomorrow. It'll be the next day. So 2 hours UTC on the 4th of February. So I will see you in 1 day and about 22 and a half hours. Okay, peace out. Thanks for stopping in.